Welcome to Robotics and Automation News webinars, where you can be part of a global event without leaving your home or office. Attend our live webinars and communicate directly with influential professionals in your industry.
Okay, John, let's start with your name and job title and a brief overview of your job and at the company you work for.
Absolutely happy to do that. As a matter of fact, I happen to have a slide for that so we can discuss it. So, name is John Hayes. I'm Vice President of Sales for Vecna Robotics. I'm also the chairman of the MHI AGVS Education Committee, which I'm quite proud of. It's an industry trade group here in the United States. Little background about myself, been in this industry for over 20 years. I started out building vehicles, and we shipped those initial batch of vehicles to Japan, put a system in Japan, and that was my first foray into automatic guided vehicles. And we're going to talk about that a little bit today, AGVs versus AMR, or what the differences are. The versus is a bit of a misnomer. It's not versus. They are, for all intent and purposes, one and the same, but the lines are blurring quite a bit as we move forward with these acronyms, and we'll talk about that. But once I moved out of installation, kind of moved into applications engineering and then into sales and sales management and into more of a strategic level position of VP of sales and marketing. And I've been at varied companies throughout my career, and a pretty rich background in automation, AGVs and AMRs. And that's really what we're going to talk about today, because I think that there's a bit of a confusion in the market about the two. And let's clear some of that up if we can, because even just in discussions that I have with people, they see mobile robotics, they see autonomous mobile robot, they see AGV, and we tend to divide those, but they are much the same. And if you look at this is kind of the line continuum of how people see them. So the line down the center kind of separates what people think of when they think AGV or AMR. So AGVs are kind of thought of as large, high-capacity vehicles, typically built on a custom frame. However, the market's changing quite a bit. One of the things that AGV vendors have always feared was that the OEM market would become more active in this marketplace in the logistics realm. And that has happened. So we have companies like Vecna Robotics, as a matter of fact, who are putting their controls on OEM tractors, whether it's a Unicarriers, who we do business with. Unicarriers actually builds our vehicles, but the concept is for AGVs, typically forklifts, pallet jacks, and tuggers, generally moving pallet loads through a facility. In the arc of cost, usually quite expensive, just because of the size of the vehicles and the safeties associated with them and those sorts of things. And then to the right of this slide, you'll see what people commonly think of when they think AMR. And really, most people divide the two based on the looks of the vehicles. Typically, AMRs are considered small, intrinsically safe vehicles that even if they run into you, really won't hurt you because they're quite light. They're moving light loads. They're also, generally speaking, inexpensive because they're built in mass versus a custom order for the typical AGV. Now, those lines are blurring a little bit, but still, that's, I think, is the concept most people think of when they think AMR, small bot type vehicles like you see on the right-hand side of the screen. However, that's really not what makes them different. That you can have an AMR built on an OEM frame, and it doesn't look like what you would consider an AMR to look like. It looks like a traditional AGV. The primary difference is this: AGV's path follow and AMR's path plan. And that is the root of the difference between AGVs and AMRs. So if you look at the left side of the screen where we talk about AGVs and path following, that's an example of an AGV path layout. And that layout is actually done generally in AutoCAD or a program like AutoCAD. And all the points that you see on that drawing, all the yellow dots, all the arrows, all the lines, all the arcs, that actually has to be manually done. It has to be tested on site, and it's quite difficult to install. The process of installing an AGV just from the beginning stage of planning takes a fair amount of time. Now, the benefit, of course, is that they are super accurate and very repeatable. But you have to modify this on site after you do it in the virtual world to make sure it lines up with the actual physical world. So it takes a lot of time. It's actually quite rigid once you install it. So, you know, the typical path following systems, going back to the very earliest ones, were wires in the floor. Then we went to magnets. Then we went to tape and paint. And to now the more common is a LiDAR-based system based on triangulation. So hanging laser targets in the facility and using them as an X and Y coordinate scheme. And that's still, even though the path appears virtual, you don't see a line in the floor or magnets if you go look at the floor, they still follow that defined path. Now, what is different about AMR is it's totally infrastructure free per se. Now, there are certain guidance methods that still use some degree of infrastructure. Generally speaking, when we say infrastructure free, the vehicles will use the facility itself. So it will map the walls and it'll map the ceiling and it'll do those things, but it doesn't require the end user to put anything in the floor or to mount laser targets. But what it really means is that they path plan. So to get from point A to point B, like you see in this silly little cartoon you see here, they can figure out a path throughout the facility. Now, when we talked about AGVs and path following, the real benefit there is that it's a defined path and everybody knows where that vehicle is going to go. And in a manufacturing or a distribution environment, that is extraordinarily important, because people need to become aware of how the vehicle operates and where it's going to go, just if nothing else from an efficiency and safety standpoint. Whereas AMRs, now by their nature, they're quite small, but the vehicle movement can be a bit unpredictable because it does calculate its own path every time it takes a path, and it will take the best path. However, in some ways, knowing where the vehicle is going to go every single time is probably preferable. But the AMR definitely has the benefit of being inexpensive and infinitely modifiable. But here is where things start to blur. And this is what happens if you take the AMR concept of path planning and apply it to the AGV concept of path following. You end up with a system that has the benefits of both. Now, it just happens that Vecna Robotics follows this paradigm, but just bear with me for a second. In our scenario, we take the AMR path planning concept of mapping the facility using LiDAR, a vision system, as well as other fiducials, whether they're vision-based or even Wi-Fi localization, to determine where we are in the facility. But we map that facility with the vehicle, so there's no real off-board equipment that's needed. And once that facility is mapped, then we constrain the vehicle to what appears to be a roadway, if you think about it in that fashion. So the system actually does act a lot like an AGV in that it's constrained to a path or a roadway, but it has the ability to calculate a path around obstacles in the facility as it navigates. So for instance, I'll give you a quick example. if you think about a typical system where, let's just say it's a train-like system or a tugger system where a vehicle travels in a simple loop, and you've got maybe 10 vehicles and the loop is six minutes to make that loop, and a single vehicle stops in that system. Well, every minute that that vehicle stops, vehicles behind it have to stop. And this is the detriment of an AGV path following system, whereas an AMR or a Vecna Robotics system, we simply calculate a path around, which means that you don't have to be, you don't have to, how do you say this? You don't have to work around the items that occur in your plant naturally. For instance, a forklift operator puts a pallet in the wrong place. What happens with a traditional AGV? It stops. It does what it's supposed to do. It stops because something is in its path. Let's say a box falls off of a pallet. AGV stops. Something's in its path. It's designed to do that. It is the safe thing to do. A Vecna robotic system sees that something is in the path, calculates a path around the obstruction, comes back to the path and continues on. Now, with that said, if something jumps into the path of the vehicle and the vehicle does not have time to calculate a path around, it stops. It uses the same safety sensors and the same, we adhere to the same principle as all AGVs do, and that's ANSI B56.5 with respect to safe operation. The difference really is that in and of itself, the system actually is autonomous. It has the ability to navigate around things within the facility. And it looks a lot like this. Can you see this video that I'm about to play?
Yes, I can. I'm seeing it.
Now, this is an example of a vehicle in a Federal Express operation called FedEx operation, where we're testing out its ability to drive around obstacles and come back to the path. And this is what it looks like. So the vehicle drives up to an obstacle, understands where it is in the world, understands that it has enough space to drive around, and continues to operate. And really, that's the difference between AGV and AMR. Path following versus path planning. And when you meld the two together, you end up with and the ability to drive around obstacles, but still have a system where the vehicle follows a defined route so that people get accustomed to where the vehicles can travel, but you get the efficiency of not stopping when something gets in the vehicle's path. Now, all that's well and good, right? You have this ability to drive around obstacles, but how do you know what's occurring in the facility? And this is really what AGV guys call upper level or path planning, those sorts of things. We call it pivotal. And what pivotal does is our upper level control system. And it ties into the plant operating systems, whether it's a WMS or whether it's a push button or a PLC or those sorts of things. It actually has visibility to the entire facility. So this is the brains of the system that has a degree of AI. So Pivotal actually gets smarter over time, whereas many systems are designed for exactly what they're designed for. And once you put them in, they immediately start to become obsolete because the one constant in any facility is change. We all know that. But this system sets above the AGV system, the AMR system, looks at the entire plant floor, generates orders for vehicle movement, not just for AGVs and AMRs, but the single most important part of this is that it also orchestrates material movement with labor. So it actually can talk to people on the floor. It can understand where people are in the facility. And it can work in a cobot type fashion for things like picking. So if you look at the graphic on the right-hand side, you'll see somebody picking. So in that scenario, someone will will get an order to pick to a bin. They'll place the bin on the robot and tell the robot to go away. But that's the cobot fashion of AGV AMR, where this orchestration occurs, where people are always part of the process. And I was asked recently, when do I think there will be a large number of lights out warehouses or manufacturing facilities? And I think that it's quite far away. Now, I've heard of at least one recently in the Far East, but those are typically greenfield, built from the ground up. The real difficulty with those types of systems is tying in all the ancillary components, whether it's talking to WMS or WCS, all the way down to talking to a robot or a person or a conveyor for that matter. The good thing about Pivotal and the onset of AI is that we have the ability now to talk to these pieces of equipment and to orchestrate the entire plant floor, even outside the plant floor, to look at demand systems, to be able to pre-allocate equipment and people to understand, based on trends, what the future is going to look like. And this level sits above all of that equipment and really learns as the system ages rather than becomes obsolete, which is kind of one of the hallmarks of monolithic automation, where you put in an ASRS or a conveyor. Once you build it, it's there, and it's built for exactly what you built it for. Now, that's the real benefit of AGVs and AMRs. You can expand them. You can change the style of vehicle, but they all communicate under this one orchestration system called Pivotal. However, the real difference that I see today, AGV versus AMR, is the growth of AMR, so the bot type systems. And like I said, I am a member of the MHI AGVS Education Committee, but this is a piece of their literature that talks about annual growth of the AGV industry. And it says 9.3%. And I would say that for the AGV world, that's correct. But that's not the whole story. This is the whole story. What I am seeing today is an explosion in the growth of AMRs. And this is all led by, realistically, what people have deemed or called the Amazon effect. And the little article on the left-hand side of the page here talks about the number of AMRs that Amazon has in place throughout their facilities. So what I can tell you is that number divided by the number per year is about, 10,000 vehicles per year since they've started implementing their Kiva systems. Now, with that said, that's orders of magnitudes higher than AGV systems in the US, based on just delivery of AGVs versus AMRs. And this makes sense. The difference is, if we go back to the original slide, the difference between what people perceive AGVs versus AMR, AGVs typically carry pallets. AMRs typically carry totes, bins, or eaches. And the world is quickly moving to totes, bins, and eaches. The growth of e-commerce, retail, and e-tail is off the charts. If you look at the graphic on your right, the projected growth of robot-powered warehouses in the world. So the 2018 number, 2,500 with 23,000 warehouses in the US at this point, but globally 4,000 versus 50,000 for 2018 to 25. That number is staggering, typically because the number of bots per warehouse is on the order of 50 to 100 and sometimes more than that. So if you multiply those numbers by the number of warehouses, this market is exploding versus the AGV market, which is growing at a sustained rate, but not at the explosive rate of the AMRs. And this is why. E-commerce is definitely driving this. And if you look at the chart here for sales just over the past 20 years, it's off the charts from relatively zero in 1998 to $60 billion. And this is still a small portion of the retail e-tail market, or rather of the retail market. So e-commerce still has a ways to go to in growth to capture some of the retail market that is starting to decline. But with that, here are the reasons that it is that the bot market is growing within the e-commerce market. It has become increasingly hard to find labor. Just in a facility recently, a medical facility, where they said, look, ROI is important to us. However, we can't find people to move product within our warehouse. If we can just get 20 vehicles in here, I can take 20 people off of a forklift per shift and move them to areas that I need. And this has more benefit to me right now than ROI. And for 25 years in me working in AGVs and automation, I've never heard that story. It has become the prevailing reason why people are looking at automation, simply because they cannot find workers to work within facilities. Of course, labor cost, it's challenging when you think about the cost of labor is going up. High level of turnover. You know, the high level of turnover that I've seen recently, and we put a system in recently at a facility where we were told that their turnover was between 100 and 200%. And that's staggering. And what we're seeing, the reason for that is wage increases. So there's competition for labor, which is driving cost up, supply and demand. So companies are looking to automate just to stave off the ability to maintain labor, as well as to find new labor. It's just extraordinarily difficult for them. And then when you think about this rise in bots that we talked about, the real benefit for the AMRs is you can add vehicles for a quite inexpensive cost to accommodate peak volumes. So you can augment your manual facilities with AMRs and AGVs and accommodate those peak volumes. One of the things that we've seen in the past, which was extraordinarily difficult, was designing systems that would operate on a day-to-day level, but then be able to hit the peak 2 times per year, with the peak being 2 and 3x. So designing a system to hit 2 and 3x when you only use it at that rate, twice a year, is incredibly difficult to create an ROI around. So the great thing about AMRs and AGVs is that you have the ability to use them as an augmentation force to your existing manual force. And that's a real eye-opener when you start to think about what you can do just to augment this workforce. And the other thing is, we talked about monolithic automation. Most of those solutions, once you put them in, they're stuck at the throughput they're designed for. You can add vehicles to AGV AMR systems quite easily. It's just the cost of the vehicle to put it in. Sometimes there's some implementation costs depending on whether the system has changed, but the capacity can increase or decrease just based on the amount of vehicles that you need for your throughput. And with that said, flexible automation, which leads us right back to AGVs and AMRs. So here we are, and this is really what it looks like. It's small, it's light, it's inexpensive. It adapts to changes quite easily. So we talked about AMRs and their ability to path plan and to move throughout the facility. If you need to add more routes, if you need to add more pick locations, it's very easily done with an AMR system. Easily handle surges, simply add more vehicles or take more vehicles away. Companies are looking at robotics as a service to be able to add vehicles without adding upfront purchase costs. So there are lease plans. There are RAS models in place for companies to be able to handle the peaks. Requires little or no fixed infrastructure. The Vecna Robotics solution uses a SLAM-based system that looks at the contours of the facility as well as existing equipment, whether it's a conveyor or a post or a wall, whatever that might be. You don't need to have fixed infrastructure like wires or magnets or those sorts of things. They're scalable from cobot, like the picture that you see at the bottom where the young lady is picking the bins, all the way up to lights out, where you see the picture above where our TRS solution delivers to our RC20 bots. Those bots take those bins over to an order consolidation robot. That order consolidation robot picks the parts that it needs for an outbound order, and then the donor totes go right back into the system. So we go from a human-led system all the way to a lights-out system, and the ability to scale anywhere in between. And they're easily managed, and they represent no single point of failure. So if you think of an ASRS, a mini-load ASRS, conveyor, shuttle type systems, generally speaking, one part of that network goes down, the entire system goes down. With a mobile robotic system, one robot goes down, you simply move it out of the way and the others take up the majority of the work, and your single point of failure is completely eliminated. Now, the key to all of this is the orchestration portion, and that is being able to see the entire plant floor, see the entire distribution center, allocate orders to the correct pieces of equipment, whether that is an AGV, an AMR, a person, a robot. The ability to have the visibility into that entire system gives the maximum efficiency that you're looking for within a facility. So it ties everything together, orchestrates everything from the labor all the way up to the AGVs and robots. And that is really the overview of AMR, AGV, and the reason why one might look at them as well as the booming market as it exists today.
Okay, thank you very much, John, for a really, really interesting presentation, very clearly describing the differences as well as the issues. If you don't mind, I'll ask a few questions. Are AGVs going to become more like, increasingly like AMRs, to the point where they themselves do become AMRs? Is there a place for what might be called traditional AGVs? Will there be that kind of requirement going forward?
There will be, and I can give you a quick example. The MHI AGVS group is actually at this point looking at being more inclusive to AMRs. And we actually have AMR companies, and Vecna Robotics is an AMR company by its very nature. And we're looking at even potentially changing the name of the group from the AGVS group into something that is more that more represents the entirety of the market, not just AGVs, but also AMRs. I think that AGV in and of itself as an acronym is looked at as an umbrella term. So old guys like myself who have been in the AGV world for 20 years see everything that falls under that umbrella as an AGV, even AMRs. However, there is a technological difference between the two. And it's important to note that it simply is not the size of the vehicle. It's not the configuration of the vehicle. It really is the way that it operates. It is truly autonomous on its own versus the path following scenario that AGVs use. But that is quickly, the AMR and AGV world is quickly blending together, because realistically, Vecna Robotics is an AMR that operates like an AGV. We have all the hallmarks of an AGV, but we fall under the AMR paradigm of path planning. And will that continue? Absolutely it will. It will have to. The benefits of AMR are self-evident. And I think that you were going to see very many larger manufacturers of AGVs start to adopt the AMR technology. And I think we're going to see that very rapidly.
As far as I understand it, Vecna Robotics well, it's probably one of the few that does such a broad range of those kind of vehicles, whether you call them AGVs or whether they are AGVs or AMRs, or you know, a combination of both, as one might argue some of them are. I don't know if I'm correct in that, but it's definitely the ones I've seen, the companies I've featured on our site tend to be one or the other, more specialized in AGVs, and then you get other ones that are more specialized in AMRs.
You are absolutely correct. 100% correct. And I think that adds to the confusion. And it goes back to probably the third slide that represented them as hardware. If you look at them as hardware, in your mind, you can see AMR is a bot type solution, very small platform vehicle, and AGV is a larger pallet load type vehicle. And I think that we are, at this point, the only company that has bot type solutions all the way up to 10,000 pound forklift type solutions as well. So we're, I think at this point, the only one that kind of marries both technologies. And I think that has a lot to do with where we started. Generally speaking, most of the folks in the AGV world have been in that world for many years, much like myself. The bot companies have kind of spun off of, in most cases, MIT and Carnegie Mellon research. And the difference really is the way that they approach the market. The AGV world is a bit reluctant to change because they're much larger companies. It takes a lot to turn a ship, whereas a small, nimble company can invest in new technology and come to market. And frankly, there is a lot of investment dollars spent today on mobile robotics. Vecna Robotics just got its first round of investment last year, going for our second round of investment now. The market is just super hot for AMRs, and we're uniquely positioned because we have that technology and have used it for AGV type solutions. So you're absolutely correct that at this point, we really are the only company doing that.
And give us an overview, maybe a couple of highlights or examples of the kind of markets that Vecna is operating. I know that maybe this is not related, but Vecna has organized itself recently into separate business units. So Vecna Robotics is a distinct part of Vecna. There are other parts which I can't remember off the top of my head, but you're part of Vecna Robotics. But yeah, tell us about the kind of customers and sectors that you're working with or partnering with or supplying.
As a company, we did split off of our parent company, which was Vecna Technologies, just last year before we went for our first round of funding. So we are now Vecna Robotics. Vecna started out as an MIT company in healthcare, and our first vehicle was what was called a QC bot, which was a hospital vehicle. And from that, we have expanded into a full range of vehicles. But our primary markets at this point are distribution and parcel. And we have had great luck in both of those. Our largest customer at this point, by far, is the world's largest retailer. followed closely by two parcel companies, which are competitors, but both have a large network of facilities that are automatable. You can actually go online and Google FedEx AGV, and you will actually see our system in operation. FedEx actually did a very nice video on our system in their Greensboro, North Carolina facility. So the market right now for us has really been, from a concentration standpoint, parcel and distribution. So hundreds of vehicles within those two market segments. We try not to be too myopic when it comes to those to markets. We know that generally speaking, the AGV market is most of the focus there is traditional logistics, being manufacturing. But we see that with e-commerce, really distribution is the key for us, as well as that secondary, which seems like a very logical step, to parcel. So we have the e-commerce portion covered, retail, e-tail portion of that, and we have the parcel section of that, which is helping with that one-day delivery that we talked about with respect to consumers wanting their product as fast as possible. We've got both of those avenues kind of covered at this point, and those are our primary focuses right now.
And obviously, you probably have customers that you've been working with for a relatively long time. It is a fairly new technology, though, so a lot of people are probably wondering how to apply it, whether they can afford it. You know, you mentioned what's called RAS, which is Robotics as a Service. As far as I understand it, it's kind of like hiring or leasing robots. But I don't know if you could, wonder if you could elaborate on.
One of the things that we're seeing now versus the past is we are seeing large companies come to us and ask us to do an audit, look at what they have. And I think it's because they don't understand the technology. They're familiar with AGVs, but they don't understand the benefits of AMRs, like we discussed earlier. And many of those companies are funding pilot projects. So we're seeing, and that's how our largest customer actually turned into our largest customer. We started with a pilot project and then grew that project into a very, very large system. So that's kind of a step method, which would be you look at the application, kind of bread box things, put some budgetary numbers against it, concept those things, and then come out with maybe a pilot before you have to put, you know, your whole foot in the water. Maybe you stick a toe in the water. But the more traditional methods still work, and those are I have an application, come in, look at it, put together some budgetary numbers, get it in the budget for next year. And that's kind of the paradigm of capital equipment purchase. That still exists in the world that we live in. And let's start from there. So capital equipment purchase, determine the number of vehicles, installation, integration, come up with a cost. That cost is the cost of the system turnkey, and you purchase it that way. That's step number one, or path number one to purchase this equipment. There's also a leasing market for mobile equipment now that didn't exist in the manner that it does 5 to 10 years ago. 5 to 10 years ago, you could purchase the equipment through a lease, but you could not purchase the soft cost, which would be things like software, installation, integration. Today, there are any number of financial institutions that will lease the entire system, which we're finding a large number of companies are interested in that and purchasing in that manner. Generally speaking, though, it's typically a dollar buyout type thing, where it's really just an equipment finance model. And then there is the RAS model, and we're seeing more of this typically in the bot side, typically in picking systems, where people don't buy the equipment. They're actually purchasing a robotics as a system type paradigm. And in those types of systems, realistically, you can scale up, scale down, and really all you're doing is renting a piece of equipment. Keeping in mind that there is some cost associated with the upper level orchestration software that we talked about, but that rolls into part of the RAS model as well, as depending on what company you're dealing with. And it is an attractive model in most cases, but I can tell you this, it hasn't gained traction in the AGV AMR world as much as I thought it would. And the reason is this. Even though engineering and plant facilities people see the benefit in automation, it is still looked at as a capital equipment purchase when it gets to finance and purchasing, which means that it's still viewed under kind of either a total cost of ownership or a hurdle rate model of my return on investment has to be 18 months to 2 years or I can't afford the equipment. And RAS models, in some cases, over time, exceed that 18-month to 2-year hurdle rate or financial model. And so it hasn't been adopted as quickly as I would have thought. The financial model of leasing has been adopted quite well. And the model of just capital equipment purchase still exists. And I think is still the most used method to purchase any of this equipment. But it is on the rise with small bot picking systems. You see more RAS models there than you do in anything.
I don't know if you could stretch beyond now and go forward into the future a few years and see how, imagine how these things might actually evolve into even more sophisticated machines possibly, and
Sure.
how the market will evolve along with it.
Absolutely. Well, it's almost a logical progression. And what I mean by that are there are still portions of the logistic market that are difficult to automate with the technology and sensors that we have available today. These sensors are rapidly evolving. The technology is rapidly evolving. The AI component is rapidly evolving. So what you are very likely to see is the portions of the system that are not automated today are likely to start to become automated. So for instance, if you think about the process of each picking, it's very likely in the very near term that mobile robots will actually become not just mobile robots for motive force, but will also become mobile robots with actual axis arm robots on board to be able to pick individual pieces. So at this point, typically, we're picking totes and bins. So we've moved down the size paradigm from pallet to tote to bin. But I think what you're going to see next will be systems that will pick eaches. So you won't need to have labor in the warehouse that will order consolidate for you. Now, today we have a system that takes the bins over to an order consolidation robot, and it can pick through the bins and pick whatever it needs for the order, and then we send the bins back in with our vehicles. But I think the long term is going to be a robot that actually drives through the facility and picks line items on its own. So it will eliminate steps within this process that occur today. One of the things that we see on the other end of the spectrum that has had some traction, but not as much as one would hope, and that is automatic truck loading and unloading. Now, we're moving away from AMRs now and talking about more traditional AGVs. There are some systems out there that do some truck loading and truck unloading, but they're wieldy and costly and very difficult because of the differences in docks, dock plates, trucks, truck floors, the way that pallets are loaded within a truck. I think you will see in the long term solutions for that as well as solutions for automatically unloading trucks that aren't pallets. So trucks that may come in floor loaded. I think very likely with the advent of the robots that go and pick eaches, you also have robots that go into trucks and pick bins and boxes and pallets on their own without having the need for any external systems or people to go into those trucks as well. So I think that where we're headed, and I think it will take some time, but I think it's driven by several things. One is the technology of AI, the technology of new sensor growth, and then it's really driven by young engineers that are looking at things in an entirely different manner than the way us old guys look at things. We look at things and go, oh, I know how to solve that problem. Young engineers are coming into this world and they're looking at it and going, what if we tried something different? And it's really those young engineers that are fostering the spirit of what can we do that's different and new versus what can we do with the tools that we have available. So we're going to see a blossoming of what robotics can do in the future. And it's all attributable to these young automation and robotics engineers that are coming out of school and looking at this with fresh eyes versus the guys like myself who've been in this industry for so long that, we think we know how to do things, but we're also tied to our perceptions and what we've seen in the past. And the world is changing, and thankfully it's changing because of these new engineers that we're seeing.
Vecna Robotics is taking part in the DHL Innovation Center in the US, sort of showcasing its solutions there, its robots there, and also you've sort of collaborating with, I think, another company called Unicarriers, which you're developing new autonomous material handling solutions with, and it sounds like a new kind of product that might come out of those things. But I wonder if you could give us a brief comment on either one or both of those.
Absolutely, be happy to. So we have partnered with several large multinational companies. DHL is one of them, where we have placed our solutions in their technology center, and it benefits both companies. It almost goes back to that pilot concept that we discussed a little bit earlier of, let's put something in, let's allow not just DHL, but DHL's partners and DHL's customers to come in, look at what technology is today and what it might be in the future. And it gives us both the ability to brainstorm where the technology could go in their operations, as well as what could the technology do in the future to meet their future needs. And I think that's probably the most important benefit that both companies get out of that. Now, with respect to Unicarriers, we signed an agreement with Unicarriers to manufacture our OEM product. And this is extraordinarily important to us as a company, because as a company that's growing, it allows us to scale. One of the things that I've seen at many companies I've been at in the past was you grow so quickly that you outgrow your ability to supply the market, and it causes a real detrimental effect to your organization. But with our relationship with Unicarriers will actually build our OEM line directly off of their manufacturing lines and give us the ability to meet the demands of our largest customers. Our largest customers came to us last year, 2 of them did, and said, we're very likely to purchase 1,000 vehicles from you next year. How are you going to do that? And I haven't been at any AGV company that would take a look at 2,000 vehicles, which happens to be roughly the AGV market in the United States, and say, yes, we can do that. Most of them would just fall over and go, oh my goodness, how are we going to do this? But we got the capability through Unicarriers to actually produce up to 2,000 vehicles next year coming directly off of their assembly lines, and we could not be happier for that. It gives us the ability to scale. It also gives us the ability to leverage their service and support network locally. So it's been a wonderful thing for us as a company to partner with them and for them to adopt our autonomy kit within their manufacturing process. So they'll just bolt it all together for us, QA check it, and ship it directly to the customer. So it's a very big win-win for both of us as companies.
Okay, John, thank you very much for your time and the insights and an overview of what is probably the most dynamic market in the robotics and automation sector from our website's point of view, at least.
Send us an email at sales@roboticsandautomationnews.com to register for one of our many upcoming webinars. And if you'd like us to host your webinar, we have a range of options, including long-term lead generation packages and marketing campaigns. We look forward to hearing from you soon.